thought it was time to end it.
Yeah, I'm gonna be
So that's my bad. I did not mean to end the stream. But it's okay. We're gonna keep an eye on shit for another couple minutes. Please like, subscribe, hit the notification bell, and show your support. We have a new membership for $2.99. You become a member. We don't really have too much in regards to that at the current time, but we're working on it day in, day out. I'm putting a lot of time and effort into doing this part of what's going on. I'm going to be putting a lot more time and effort into doing other parts as well. We're going to be trimming up the channel. I know it seems like I might have just dumped the whole stream, and I guess I did, but I did it on accident. It was not on purpose. So I don't know. I want to end on a good note. I feel like I dumped off a little bit too early. Yeah, we'll see what happens. So, I mean, the new format for my live streams is I like to keep it around an hour in length. Try to get done about as much as I can in an hour. If things are going well, we might go a little longer than that, but usually 55 minutes to an hour. So,
what are you making?
it's a pulse motor. It's a closed loop system. It's got an SSG and an SSG with gen mode, 2 cap banks, 1 battery, 2 coils, and a rotor with 3 magnets on it at 120 degrees. We got a 1,000 ohm potentiometer, and each circuit has 680 ohms in it. So I apologize for anybody who was in the previous stream. I did not mean to close up shop so rapidly. So if you're interested in becoming a member, we've got a really good deal going on forever. It's a member for $2.99. You can become a member. I throw my 3D printer on the line here as a member. For a few months of loyalty, you'll get a free 3D print. No? Discounted. So you gotta pay at least for shipping. We'll figure it out. So not free, it's not a giveaway. It's a discount. I stand corrected. I believe that when we had our previous format, that was the deal, but it was, $30 basically. 8 times more. Yeah, they're not free for me to make, so yeah, it's gotta be some kind of reciprocity at the current time.
I think you should pick up the phone. So they can get processed.
Okay. We're gonna zoom in on what we're working on right now.
We'll just work copy working.
All right, so we got the SSG, and the output goes to this cap bank right here. So the AC or the DC goes in this side. It gets rectified there in the middle. Those are bridge rectifiers. And then out the end with the DC caps right there. And then it goes from that cap bank to the input of that SSG. So it goes, the output goes from there to the cap bank to the input of the other SSG. So it's all one big circuit really. Except the output of that circuit is a lot more than the output of this circuit. But the draw from this circuit is a lot less than the draw from that circuit. So I combine the two to try and get some sort of unity. So far it's working. So far it is working. 11.99. It's actually gone up 0.02 of a volt since we started the stream. Or since I started, I forgot what I did, but during the stream. I think its lowest value was 11.96. Now there's another cap bank over there. So the output from the SSG gen mode goes into that cap bank and then gets directed back to the start battery or the primary battery. So yeah, each circuit here has 680 ohms of resistance for a baseline resistance. And then I have a potentiometer on top of that for the SSG circuit or the drive circuit. Now, this meter in the middle is the voltage that's coming out on the output of the SSG over here. So this SSG's output is right here. It's like nothing, right? 2 volts max. Okay, and then it goes in to the cap bank. Okay, and any excess that you're not using gets stored in there, okay? And then anything that you draw on from the cap bank gets used by this circuit. So it should be using most of it, if not all of it. And then this is the output from the SSG with gen mode. So the output is definitely increased. I think it was increased more when I had it all in that coil right there. But now I split it up. I got it in two different coils. See, and there's another coil there. Now that the SSG gen mode is hooked up to. So there's 2 coils, 1 rotor, 2 circuits, 1 battery, and 2 cap banks. And that it's a closed loop system, but I'm pretty sure that'll eventually go down. If you're looking for a way to get a circular object to move, to spin at a rapid pace, Circuitry is one way that you can do that. You need a coil though. I mean, coils can oscillate. Coils, and that's basically you get a frequency. Um, I think it's basically made by the bifilar experience when you're using an SSG circuit to do it. But
That's one good thing to tell someone new about circuitry.
yeah, I just did that.
Oh, sorry.
That's all right. Good evening. We're looking pretty good here.
It was all divine and meant to be.
What's the poll?
The 11.99. What if it goes up to 12 again?
Well, then that's miraculous. That really shouldn't happen.
That should not happen. Then that's not an again. Sorry.
No. I mean, like if that happens, man, I will do a flip. Like I said, I will do a flip, especially if it goes up 2. I will do 3 front flips before I hit the ground. But we'll see what happens. So there is a great deal more DC output for the less input. See, this is the output of the other circuit, which I'm inputting to get this out of the other circuit. Now, if I had a way to measure exactly how much I was spending, then I could get excited about that. But I do know that the output of this SSG was not enough in any way, shape, or form to make it work. But see, right now, what I'm doing is I'm using the SSG's acceleration and the SSG with gen modes, gen power. But the problem, cost, it's cost electricity, enough electricity to run 2 circuits off of 1 battery. So there's cost involved, but it's not enough cost yet to make that go down to 1198.
Mike does is in the house.
What's up, Mike Does? How's it going, Mike? So I've been talking about the 380 ohms, man. That's some magic number. That's great. Thinking I'm making a coil out of 24 gauge and 26 gauge to, be that size. So we got the SSG driving the thing on this big coil right here. And then its output is driving that SSG with gen mode on a different coil through that cap bank right there. So it's actually running to a cap bank, which has really got throughput going. So you have to have something hooked to both sides of this cap bank for it to work in the first place, really. You can store stuff, you can store energy in it though. Like if I unplugged, not these 2 ends, but these 2 ends. No, that's not right. These 2 ends. Then these lights would light up really bright and this cap bank would start to fill up. The fact that there's no light there is a good sign. It means that the energy is being spent. Make crack like this. Make crack. Yeah, I don't know, man. I gotta have some fun with it. So
Fun, but not copywritten.
right.
What's up, society?
Hey, society, what's happening, man? So we got closed loop system. I'm gonna name all the components real quick. We got 2 coils. We got 1 rotor with 3 magnets on it at 120 degrees. We got 2 SSG circuits, 1 regular SSG, 1 SSG with gen mode. Each one of them has their own coil. So we got 1 battery. We got 2 cap banks. I'll go through the circuitry real quick. It goes battery to SSG to cap bank to SSG to cap bank to battery. That's the circuitry. Now you can use any coil that you want, really, but you're probably going to get the best bang for your buck from a 380 ohm coil. Hello. I hear you. I was thinking about putting this one up to 24 volts and like using it batteries in series. Oh, with ferrite instead of neos. Gotcha. Yeah. I think it started to move the wrong way, but maybe I'm just blind. All right, so one more time, we got a multimeter hooked up to the battery that is now 11.99. We got a multimeter hooked to the output of the SSG, which is generating about in between 1 and 2 volts. And another meter is hooked up to the output of the SSG gen mode, which is receiving this as input, and this is what's coming out. But what I think I'm going to do for a future stream here is going to put both of these circuits into that one coil right there. Split it down the middle, do 830 turns of 20 gauge in each circuit and 830 turns of 32 gauge in each circuit. And that way the transformer or the bifilar interaction is going to change these outputs drastically. Because right now they're in solo coils. They're, this one and that one right there. But when I throw it all in there, we're gonna see some interactions that are gonna send these readings to another level. I think actually this one's gonna go down by about a volt, maybe 2 volts sometimes, and this one is gonna go up to about 9 or 10 volts. But this side is the gen side, when it's all going on in the coil. And I don't know exactly why that is, but anytime when it doesn't matter how I hooked it up, the one on this side genned and the one on this side did not. So it's like it followed a Bedini style, primary charge battery. It didn't matter how I hooked it up. There was a primary and a charge battery. It didn't matter how I hooked it up. It really didn't. Didn't matter what I added in component wise because everything's it's in the coil. You can't separate it because it's in the coil. And it's a really powerful design. I mean, once you turn it on, the other drive gets saturated to the tune of about 7 volts. So you have to turn it up to 7 volts before you start hearing it rev up. And once it gets past 7 volts, it revs up really, really hard up to 12. And this is with 2 power supplies on it. So I know that the quote unquote dual drive is very powerful. But it's only at this point a 12 volt parallel system. The max voltage is 12 right now. And it's still powerful, man. It's like unbelievable. I can't let it run, especially with lights as a load. And this is I don't know, that LED in that lamp right there. I hooked that up and it just increases the speed that it goes by a lot. And I think it has to do with some oscillation or, it goes into the light and then it comes back through the light. There's a lot more energy going through that line than the light needs. So it comes back into the system. So yeah, 11.99. I'm excited kind of to see how long that lasts for. I don't know. I kind of want to hook up the dual coil thing right now, but I don't. I don't really. I don't want to do it. Not right now. It's too late. And I don't want to mess with 32 gauge right now. My eyes aren't good.
Yeah, this is doing good. Just talking about it. Talking about what's already there. Let's work it.
Heck yeah. So, with the resistance really high the way it is right now, let me gauge how high it is. See, there's my pot, and it's really about a little more than halfway. So I'd say right around 600 ohms on the pot. Maybe 550 on the pot. And then 680 ohms right here. And 680 ohms over here. So that's 12, 1360, and 550, 18, 19, 10. Like 1910. Literally like 2000 ohms. A little under that. And look at how fast it's still moving, under 2,000 ohms of the rest, man. That is freaking awesome. It's an axial flux design. And I want to turn that resistance up a little bit, but
Probably comes of the LEDs at a different variable that makes it faster, like variable speed control.
yeah, something like that. Um, the way that it pulses, I'm not sure, but the batteries as a load are very much slower than the LEDs. There might be some sort of circuitry in the LEDs that make them run better. I'm not exactly sure. That's all right. Um, this build is a closed loop circuit. It's got a potentiometer. It's got roughly 2,000 ohms altogether on it right now. So it goes from the battery. This is the path that the energy takes. It goes from the battery to the SSG to the cap bank in the output to the SSG with gen mode input. Then the output from the gen mode goes to that cap bank over there. And then from that cap bank, it goes back to the battery. That's the circuit. Now the coils are 1,660 turns of 20 gauge and 32 gauge in this coil. And then 1,460 turns of 20 gauge and 22 gauge combined with a trigger of 30 gauge at 730 turns. So the trigger's a little stubby in the other coil, so you don't get full bifilar action on it. But this one's literally awesome. So there's like 1,600 turns of straight bifilar, the way it is right now. But it's really a 4-filar coil because it's 830 turns of 2 turns of 20 gauge and 2 strands of 32 gauge. So there's 4 strands altogether. The 20 are in series, the 32 are in series, and they're all going into this SSG right here. Man, it's a beautiful coil. It's got so much possibilities to it. So literally what I can do is I can take these clips out, this clip and that clip right there, and put one of those strands into that circuit and one of these strands into that circuit, and well, bam. I don't know, man. I love the power involved. But with this closed loop circuit, this is probably a better way to run it. Still $11.99. Because we get the speed of the SSG with the output of the SSG gen mode. And yeah, we got our membership straightened out, so please like, subscribe, hit the notification bell. Everything is good here. And join up, man. Become a member. See what's going on. Yeah, we're just doing stuff like this. I do take suggestions. I do have a 3D printer. I'm saving my materials for more important ventures. I blew a lot of it just messing around, building rotors like this. Like this. I like this rotor. Now this rotor is more capable of disrupting time than, say, another rotor. Like this rotor, the permanent magnets are on the rotor. The rotor over there, the electromagnets are on the rotor. So it's a little different. It really is. It might move and spin the same way, but the imprint that it's leaving in the ether is way different. Nice, dude. Nice. Now, granted, that thing is moving pretty slow, but I think it's what we need to win here. So, yeah, I got the closed loop system going from this battery to the SSG, from the SSG to the cap bank here, from this cap bank to the SSG gen mode, and that output goes to this cap bank, and that cap bank goes to this battery. What I really want to do is I want to hook up the 24 volt capacity, and I want to hook up this battery in series with this one and see what we can do with 24 volts. I hope you don't mean like yourself.
Oh, you want me to? You just want yeah, you pick it now, Phil. Get ready.
What do you want, Phil?
Did we scare him off?
I don't know. He's probably lurking, but
You play with the pancake around.
a little bit. I mean, I never really got a good way of building it, so or any good wire for doing it with. But I got this one. It's a little fat in the middle, but I got another one lying around somewhere.
Sorry.
It's all good, dude. Yeah, but I'm probably not. I mean, maybe. I think I do have some wire that I could use for that.
Pardon me. Pardon me.
Bam! Wow, man. I mean, and I know what's going on. I know that I'm just milking it because it's gonna go down, but I'm not. I'm not. I'm not bedazzled, is what I should say. But look at it go, man. It's 11.99. Oh my God. We started at 11.898. 98, my bad. 11.98.
Induction stove, coils. Stovetop.
Mm-hmm.
I will take a look out for
I'll keep that in mind. But I mean, with my memory being as bad as it is, I better get it tattooed on my arm or something. Mm. Yeah, I'm not interested in doing anything that I can't, that isn't like clean cut, straightforward on how to do it. I'm really not interested in learning right now. I don't care about learning right now.
Cutthroat, Shark Tank.
I learn, but it's not like something that I do intentionally. It just happens. So like if there's like a definite way, like I'm just thinking of a tool I could use. Maybe just a roll of paper towel, an empty roll of paper towel. Or maybe even like this roll of tape and start like that. But I don't have anywhere to like measure out the wire, dude. There's nowhere for me to do that. Um, I can measure it out in my room going back and forth. I have 2 hooks on my walls and I can do 16 feet at a time. So I can measure it. Yeah, I can do it. It might be fun. You got a length of wire that I should use for doing a bifilar? Thanks, Mike. What am I learning right now? Right now, I'm not really learning right now. I'm just, I'm looking for questions people are asking about what's going on and answering that question pretty much over and over again.
That's a live streamer.
Hell yeah, that's how we do. So this is a closed loop system. And that's the battery reading for the closed loop system. 11.99. It was at 11.98 when we started. The battery starts here. Look, man, if I can't build it, I really don't don't mind. Doesn't bother me either way. Oh, but yeah, I've tried using that one. I don't know if it's got the vortex thing that you were talking about, and that's what I'm talking about. If that part of it isn't easy to build, or is it already into it? Is already pre-built into it? Because if that part is not easy, I don't know. Because this was difficult. This is speaker wire, but it's really firm speaker wire. I wonder where my other one went, dude. It's really bugging me. I can't find it. And I know that's not to spec bifilar coil pancake by any means. But I mean, and then trying to use this one has like, I've blown out stuff so quick with that. Because this is like a 12 gauge wire, stranded. Maybe if I use the input like that. Like that. Man, I wish I knew. I wish I knew where my smaller red and black one was, because it's like a pristine shape, and it's a smaller gauge wire, and it's got a smaller center hole. And I think it's made out of this. Hey, Yanni. So I need to really look into where all my stuff is. I know where it is. I just need to find all of it. But yeah, man, I get into the it's not a Tesla coil, but it's a Tesla design, isn't it? The bifilar pancake coil. I'll put this one over here just to hold on to it. Hello, Patrick. This is a closed loop. Currently, that's the battery multimeter. It's at 11.99. It's been there for 40 minutes, 45 minutes. Started the stream 45 minutes ago. Yeah, man. I get that. The ghost like static effects because I mean, like the ghosts um, function on a way different wavelength, and maybe that the bifilar coil gets in touch with that wavelength. All right, let me run it down real quick. You got the battery. The battery goes to the SSG to run it. The output goes to this cap bank. That cap bank goes to the input of that SSG gen mode, and the output goes to this cap bank. And then that cap bank goes back to the battery. Well, bam.
Well, bam.
So that was a really awesome stream earlier today with old man and Sean. But you know, I'm a dad, dude. I get pulled in 1,000 different directions every day. So it's like, and my kids are still young. That's why that is doing that's happening. Because I want to be a part of their lives while they're young and old, and just hopefully I get to do that. Continue to do that. Nice. Heck yeah, man. Yeah, I heard that's when I cut in when you guys were talking about that. I didn't know what you were talking about, but I get it now. Yeah, that's cool. I gotta make a better coil than the one I got though, man. This that thing will blow up any transistor you try and hook to it, any capacitor you try and run on it. It's it's a good prototype, maybe. Oh man, this is the second time the multimeter has turned itself off. I'm always nervous when I look at that, and I'm like, it goes off. I turn it back on. I'm like it's gonna be over when I turn it back on, man. It's over. This is a closed loop circuit. It's actually two circuits. So you got your battery, your SSG, your cat bank that feeds your other SSG, which output feeds a cat bank, which regens the same battery you're spending from. So I'd say that's pretty good. Um, it has 680 ohms plus 680 ohms, so that's 1330 ohms, 1320 ohms, 1360. And then you got a potentiometer on top of that. So, and it's like at 700 ohms. So you got literally 2000 ohms on both of those circuits combined. But it's causing us to win. I mean, we're winning because, and we're winning because it's not going down. That's why we're winning. We're not going to be presumptuous enough to say that it's going to go up in a closed loop circuit, but we're definitely going to say that it's not going down. I know the impressions that you're talking about, society. I, I I see stuff like that. Uh, I used to, and I would have to wager that it being in the 80s and stuff that it was because of some older electronics in the area. Mm. Hello. I think I'm gonna leave this running tonight. If it doesn't like drop off in the next 10 minutes, I'm gonna leave it running. And so I think upping it to a 24 volt system won't hurt it at all because it'll be a 24 volt load as well. It's not dead quiet, sir. Turn your speakers up, Sean. Thank you, Yanni. It's a closed loop pulse motor. It's running on 2 SSG circuits right now. So we got the drive, basically running on the 12 volts for the SSG, and then its output is being filtered through the cap banks to that SSG, which is running on its output. That output is, you get what I'm trying to say? I'm running this SSG with that SSG's output. And then this SSG with gen mode's output is going back into the battery. And that is the voltage reading for the battery. It's been like that the whole stream. You can go ahead and yeah, I get lots of different information from them. Chat. You can go ahead and tell them. Because the SSG with gen mode harvests back EMF, so that is part of what's going on, yes. But I do believe that most of that energy is passed by using the regular SSG because you don't have the reverse diode in place. Yeah, I'm doing it right now. Not without the cap banks, I haven't been able to do it. But the cap banks have bridge rectifiers in them. So yeah, it's more than possible. Hey, what's up, Hall Effect? What's going on, man? Here's the man right here. He taught me mostly everything I know about what I'm doing right now. Hall Effect X. You the man, man. Yeah, Sean, what is it that you don't understand? I didn't say you were or did. I'm sorry. Hall Effect is who I was talking about. Well, what I was thinking about this circuit is I didn't have two of the SSGs. I have got one of each. So I decided to utilize the drive capabilities of the SSG and the gen capabilities of the SSG with gen mode. And right now I'm using the best of both worlds. One battery. No, yeah, thank you, Society. Sean, it is not a perpetual motion machine. For one, that would be continuously increasing if it was a perpetual motion machine. Um, well, with using, thank you, I appreciate that. Using the two circuits, it cuts out like a lot of wiring that you would need to put in place of it. Well, really, what there is a reservoir of energy building up here. That's why it won't go up, because it's just slowly draining the cap bank from. But what is good here is that there's enough energy uh, being generated that there's actually buildup in the caps. This is the one that we're really looking at here. This is the one that's going back to the battery. Look at how bright that is. Look at how bright those lights are. There's so much buildup in this cap bank right now. But it's only going to take what it needs based on what it's spending. I'm pretty sure that's what its marginal cost margin is, what it's spending. But I'm almost pretty sure with the way everything is right now, it had to fall to 11.99 to get into this rhythm. That it would, last for a while. It's been an hour now at 11.99. It's very close, yes. I'm thinking of what else I could do. Honestly, judging by the brightness of those lights right there, I think this could last for a while. I mean, these lights aren't bright because that's it's all being absorbed by the SSG gen mode. But here it gets to build up because what's being drawn from the battery is minuscule. It's SSG. It's if you've worked with SSG, you know that it doesn't cost much to run. So I think this will. I don't know. Don't want to be presumptuous, but I think tomorrow it's going to say 11.99. Yeah, man. Lead acid batteries are really good, and they're in good condition too. The pulse motors keep them going. Oscillating coils will keep them going. But it all pretty much does the same thing. And you know, I was getting with the double with the double pounding on the coil. So you got your baseline and then you got your frequency generator. So I was getting peak to peak of, you know, over 1,000 volts, not 300. So I mean, it's nowhere near the same like intensity. But I'm gonna try to oscillate both of these circuits inside of that coil. Hello. It's a closed loop system. We're running from the battery and charging the same battery. That's our battery voltage. It's been like that for a long time right now at 11.99. So I think we stumbled onto something that might work. Um, Heck yeah. So I got the little disc there to prop up the coil just a little bit more. And that, you got two toroids on the bottom and one toroid on the bottom of the disc. And I know it looks wobbly, but that's just the tape that's on the edge. Tape is wobbly. That's really close. There's barely an air gap there between the coil and it's two magnets, two cubes stacked on top of each other. So it's really powerful neodymium power going on there. It's two neodymium cubes stacked on top of each other facing north down. It's not really. I'll explain it to you. And we're going to go from point A to point B to point C real quick. All right, we go battery, SSG, SSG to cap bank to SSG, SSG to cap bank back to battery. That's 4 dots. Yeah, I know, right? It does span over quite a ways, quite a while. It's not a little tiny thing because I'm not a good solderer, so I use clips. Besides, man, if I screwed up, I wouldn't know what to do, man. I'd have a coil with an end that's too short and, you know, nothing to do with it. I have to throw it out. I'm not getting there. I'm not going to go there. You know, if it's going to be broken, it isn't going to be broken because I broke it, you know, or like that. But I don't really know anything about it. You know, if somebody could teach me like how to break it down and do it simply, maybe it could look different than this. But this is how I know how to do it, so that's how I do it. All right, so we got the battery goes to the SSG. The SSG goes to the cap bank. All right, so the cap bank has got AC caps, the little yellow ones, and bridge rectifiers in the middle here. and DC caps going out the other side. So, and then it goes to the SSG gen mode. The difference between gen mode is this one has the diode facing, the way it goes. And this one has two diodes, one facing the way it goes and one reverse diode. Okay? And that's the difference. And the genning is way different. It's like way better. So we got the voltage going in here, and we got the output from here going into there basically. And the output from there is now going back into the battery. And we're getting more output from that one than we do from this one, and we're getting more speed from this one than we do from that one. So them working together is like the only way that they really work. I'm sure that if you weren't typing that out, you would have figured it out by now. Yeah. All right, you want me to go through it again? Yo, freshness, you want me to do it again? I can do it again if you missed that. All right, hell yeah, let's do it. We got, and I'm only going to do it for you one more time, all right? We got battery going to SSG. We got SSG going to cap bank. We got cap bank going to SSG with gen mode. We got SSG with gen mode going to cap bank. We got cap bank coming back to the primary battery. Is that too fast? Well, the SSG, let me think here. There's probably some really scientific data for it, but what it does is it'll run your coil, and then it'll take the existing energy that isn't being run, and then it'll filter it through what the output is. So basically, this diode is connected to the end of your collector, and then the other end of the diode is connected to your output. And that's basically what it is. It's a continuance of the energy that isn't being used. Now there's a few things on here that I don't really know. There's a Zener diode. I don't use Zener diodes. I should probably start. There's a resistance in between the light and the emitter. But the emitter is drawn between the collector, the light is drawn between the collector and the emitter. Now I could flip this over, but I'm not going to do that. Not today. Oh, I don't know, dude. I don't care. Oh, you're good, man. Seriously. Don't get me revved up, man. Give you a classic warm welcoming from Detroit. Not quite sure what that means, but it'd be like, howdy, partner, from Detroit. No, I'm kidding.
Come on, man, that's out of context, bro.
I got him. I got him. All right. Yeah, man. 24 hours. You can cool his heels for 24.
24. Space.
No, it's cool to have like side conversations and stuff, but keep it topic related.
We cannot just leave him in space, man.
But we cannot go out there without the radiation shielding.
Right? Oh, whoops.
Don't
My bad.
make me SSG on you. Oh man, I'm sorry, dude. I don't know what you're talking about.
Oh, this guy. This dude. Peace. Yeah. It's like, what?
Sorry.
Yeah.
No, I'm not. I'm really not. I didn't ban him. It's not like he's gone forever, but he's not going to see my face for 24.
24.
I'm sure that he considers this a victory for him. I'm pretty sure that's what he's thinking right now. He's like, yeah, I got exactly what I wanted. I am all powerful. I made him do what I wanted him to do. And I'm like, yeah, I did it. Congratulations.
Like and subscribe.
Like and subscribe, hit the notification bell. Join up, man. Memberships are down to $2.99 a month.
Discount.
Mm.
One single. We got 10 likes.
Mm.
We got 10 subscribers.
Should I leave it like this, or should I turn down the resistance and let the wheel buck a little bit? Well, I like to keep it bipolar. So if that's what it is, magnetic, absolutely. I'm there.
Mm-hmm.
Mm-hmm. Mm. I knew it was Yimmy and Yanni. Man, the whole 9 yards, and then the whole 10 yards. Is that what the other one was? Oh man, yeah, I've been bipolar since I was 2.5. Bipolar 1. I was climbing out of my bedroom window at 2.5.
Respect.
I was huge, man. I'm still big. True that. I don't think that there's anything wrong with talking about it because I mean, it's the same thing, man. It gets us through, and then at the same time, it's a big burden at times. But I wouldn't have it any other way. Seriously, I wouldn't wish for it to go away ever. It's part of me. It's who I am. Yeah, the quietness, man. It's amazing. You're right. But here, let's see if we can get it to chirp a little bit. No, I'm good. Yeah, I was lighting a lighter, but hell yeah. I went over to the neighbor's house because I liked them, and they were they gave me back to my mom that night. Huh. Here, we juiced it up a little bit and it went down. See? But it's chirping a little bit. It's making a little bit more noise, right? But yeah, I do notice how it is a little bit quieter than other motors. Oh, electromagnetic field? Heck yeah. And I found out that the smaller, fatter coils, what I mean is thicker gauge with less turns, provide a more powerful punch for immediate gain on your motor. Now, granted, if you it costs a lot of amps, and if you leave it running for a while, it's not. It's gonna, end up in second place to say a bigger coil. Because when you get more inductance and you throw more voltage into it, you get more potential return, like a lot more. Yeah, me too, man. It's yeah, it was weird how this motor ended up being so quiet. Oh no, I'm holding it right now. It's like right next to my face. And usually I have it up on a tripod. I'm usually really far away. See, when I get it really close, You can hear it really good. And thank you very much. I appreciate that. Normally, I don't have good sound quality, so I think holding the camera is a good way to go. And maybe not doing so much live experimentation, maybe just letting it roll like it's doing right now, and then maybe talking it out. See, I think we can turn down the resistance, and this will go down to like 11.96, but it'll level off again, and it'll stop going down again because of this cap bank situation where the energy is built up behind the battery that needs it. But I don't know. Honestly, I can't really, I mean, deep down in my gut, it tells me that all this energy is flowing in a circular motion, right? But then, the numbers of what's being spent and what's being generated have to be so close that it would make it level off, be like unity. But the way that this is working out, it looks like unity can be whatever number I want it to be in the voltage, in respect to the voltage. But right now, it apparently I won't be able to get it up to 12 to go up anymore. But let's look and see how much variable resistance we have available to us, like 300 more ohms actually. Hello, all right, Hall Effect. Cool. All right, so looks like now we only have like 150 ohms left. Maybe 50 ohms now. Nope, it sounds like it turned off. Because when you get it really far down the end and it's like 999 ohms, it might just turn off on you. Yo, yo. But I want to test that theory that I just had before we go. I'm going to turn it up like halfway on the pot here. We should gain I don't know, 100, 150 RPMs. Maybe more. Heck yeah. And there it goes. But that's okay. I expected it to drop a little bit. Heck yeah, man. Yeah, I don't know what I'm looking for, dude. So it doesn't matter. Oh, I've watched a lot of his videos. Don't know if I recall the exact video, what you're talking about. But yeah, I've watched the video several times. I just don't remember a lot about it. I remember him telling me not to switch the switch when it was on, and I never did. That I can recall. I do remember that it got fused, the switch, and so I asked him to build me 2 circuits without a. Well, he offered to build them actually to solve the dilemma of the broken switch. So like, I'll build you 2 without switches, one, with gen mode and one without. No, I rarely do anything like that, Yanni. Like ever. I don't go looking for schematics and how to build stuff and all like that. I ask questions. Like if I'm interested in something, I'll ask questions. Now, I was running a lot of my own experiments, and I thought the SSG circuit looked cool. I wasn't interested in replicating anything. Even if it would run better, I'm not interested really. And I don't mean to like be rude or anything like that. I like doing my own thing. Mm. Now the one that reads frequency, let's see if we can get this one to read frequency. Let's go menu. No. Mm. So let's go back out to the signal generator oscilloscope. Let's try that. And it's DC, so we're not going to get any waves. And that's just because it's on the output of the SSG. So it's, and this is AC voltage. So I wonder what the dealio is with that. That's good though. That's a more solid reading than we've had in a long time. No. It's a DC. No. It's hooked up to the one that reads the frequency is right here, and it's hooked up to the battery. So the answer to that question is no. So there's the oscilloscope. Now we'll get out here and we'll go here. There's the AC reading, which is 0. There's the Hertz reading, which is 0. And there's the frequency reading, which is 0. Or the duty cycle. So Hertz and duty cycle are both frequency. It's on the battery, and I'm not going to move it right now. Let's see about... Yeah, all that stuff seems too complicated right now. I'm not going to do that. I could hook it up to the coil, the main coil right there. But if it touches anything else around it, it's going to pop, and I'm not doing that right now. But I will keep that in mind that you guys want to read the frequency. I'd say it's right around 200. I wonder if we hook it up to a resistor that's hooked up on that path, if we can get a good reading on the coil. What do you guys think? What's up?
Jeffrey Dahmer's talking smack.
Jeffrey Dahmer's dead.
That's a good point.
What's up?
I love it, man.
Oh,
Yeah.
good. I'm glad it's something cool instead of... So I'm wondering how I do that with this frequency. Here, let's try this. We'll go here, we'll go oscilloscope. Yeah, I don't know. Here, let me try hooking up the other one. Alright. Here, bro. I need you to hold this. Bro? No, you gotta come over here.
No.
Alright, ladies and gentlemen. Peace out. Have a good night. Please subscribe. I'll get back to you later on, but I gotta take care of some business real quick. Bye now.